Hello guys, welcome to my channel. Today's class is how to calculate the pure orbitals and what are the pure orbitals and what are the hybrid orbitals and how to calculate pure orbitals and hybrid orbitals. And in sometimes in exams like competitive exams they will ask what is the ratio between hybrid orbitals and pure orbitals. Sometimes they will ask the how many number of sigma bonds and how many number of pi bonds present in that. So you should know the how to calculate the pure orbitals and unhybrid orbitals. Before, so many of them don't know what is the pure orbitals. Pure orbital means none other than unhybrid orbitals. Means you are finding the ratio between hybrid orbitals is to unhybrid orbitals. Most of the competitive exams they will ask any of this question or they'll ask the ratio between the pure orbitals and hybrid orbitals. So many questions they are asked before the exam. So we should know how many should find if they're given any organic compound, they are given organic compound. In the organic compound, how many number of unhybrid orbitals and hybrid orbitals. If you they ask the sigma how many sigma bonds and pi bonds, you will get very easily by varying the structure. But how many number of hybrid orbitals? How can you say that? You can before class I said the hybridization means how many number of hybrid orbitals present in the molecule. Means you by this day you can say that it's an sp, 2 means sp, 3 means sp2, 4 means sp3, like that. But how many number of hybrid orbitals and how many number of unpaired unhybrid orbitals? We calculated their hybrid orbitals only. But in the organic compound there is hybrid orbitals and unhybrid orbitals also there. So we should calculate both of them and they will ask their ratio. They will answer, sometimes they will answer directly or some ratio they will ask. So here today's class I will explain the how to calculate that ratios. So pure orbitals. Pure orbitals. Pure orbitals is also known as unhybrid orbitals. Unhybrid orbitals means which are not not at contact with, means which are not participating hybridization are called as pure orbitals or non-hybrid orbitals. Does not participate in hybridization. So these are pure orbitals means does not participate in hybridization. They are also called as unhybrid orbitals. Okay. So sir, how to find the pure orbitals in an organic compound? So, organic compound, we know that any organic compound there is the carbon and hydrogens. It's a common thing for organic compound. So number of means pure orbitals. I'm saying pure orbitals or unhybrid orbitals. For this formula I'm saying it's very simple. Number of hydrogen atoms plus 2 into pi bonds. Here it is the formula for the pure orbitals. Here you know if you read the structure, you will definitely find out how many hydrogen atoms. Before structure also you can find out how many hydrogen atoms connected, and 2 into pi bonds. Pi bond means if you see the double single bond means is a sigma bond. Double bond means one sigma. 1 pi, 1 pi. Triple bond means 1 sigma. 1 sigma means I am writing symbol also for your understand, and 2 pi. So here is the difference between sigma and pi. So if you see, by this you can, by varying their structure, organic compound structure, you will see how many number of sigma bonds and how many number of pi bonds. If there is a single bond, it has only one sigma bond. If there is a double bond, it has one sigma bond and one pi bond. If there is a triple bond, means there is a one sigma bond, another has two pi bonds. So by this way you can calculate how many number of pi bonds. So after that you put it in here, you keep this pi bonds, number of pi bonds into this formula, then you will get the number of pure orbitals. Let's say some examples, and how to calculate the ratio also I will explain in this now. And how to calculate hybrid orbital, I already said how many number of hybrid orbitals I asked it. Okay, but here we see here example. By the example you will understand very well. For example, I am taking ethane. Ethane. Ethane means C2H6. Ethane means C2H6. Means alkane. The structure is CH3 bond CH3. You will generally write it. If I open this structure, I will write it as like this: H, 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 bond C, bond H, H, H. Okay. Here, if you see, here there is a single bond. Here. So it gives sp3 hybridization of this carbon and sp3 hybridization of carbon. If you see, here I am writing simply, if there is carbon has single bond, it's sp3 hybridization. Means here sp3 and here sp3. And seeing double bond C, this carbon is sp2 and this carbon is sp2. 1 minute. This carbon is sp2, this carbon is sp2. If you say C triple bond C, this carbon is sp, this carbon is sp. So in the organic compounds you can directly know the value of this sp2, sp3, sp by this the bonds only. So no need to worry. By this simple trick you can know the how to what are the hybridization. You will feel difficult. There is a single bond. What is the sp or sp3 something. So if you see the single bond between the carbon attached, means there is sp3. If you see C double in between the double bond means sp2. This carbon is sp2. This carbon is sp2. So for example, we'll continue the example. Here, if you see the carbon as I'm not considering the H's. No, I'm not considering H's. I'm only seeing the carbon and carbon. Carbon has only one single bond. Single bond means we said it's sp3. It's sp3. 1 minute, I'm wearing the big diagram here so that you can understand very well. So here it's sp3. This carbon also sp3. sp3 means how many hybridals? 1s, and p3 means total 4. Here 4. So these are the hybridization. These are the hybrid orbitals. You should only calculate for the carbon, not another molecule. You should only calculate for the carbon only which is involved in hybridization. Okay. Number of hybrid orbitals. Now I am calculating number of hybrid orbitals is equals to here 4, one carbon has 4 plus another carbon has 4 is equals to 8. Now, how many number of pure orbitals? By the formula, we know that number of hydrogen atoms, first you should calculate. Number of hydrogen atoms means 1, 2, 3, 4, 5, 6. 6. I am writing like 6 plus 2 into how many number of pi bonds? If you see here, there is only single bond here, so no, there is no double bond present in that. If you see only double bond or triple bond, then it's supposed to be have pi bonds, but there is no double bond or triple bond in this diagram, so there is only single bond, so there is no pi bond. That is also sigma bond. I'm writing 0, so it's calculated is equal to 0. The PV is equal to 6. So here we am writing the ratio between hybrid orbitals is to pure orbitals. 8 is to 6. I'm getting 4 is to 3. This is the ratio. This is the ratio for the ethane C2H6 molecule, hybrid orbitals, pure orbitals ratio. Then 4 is to 3, we got it. So how many number of sigma bonds present is that? You can find it directly by wearing the diagram, but sometimes you don't know how to wear the diagram, don't know how to wear the diagram. So sometimes directly you should find if there is how many sigma bond present in that one. If you wear the diagram, it takes more time. Before wearing the diagram, you can calculate with number of hybrid orbitals. Sigma, number of sigma bonds is equal to sigma atomicity. So atomicity -1. It is the formula for sigma bond. It is only for straight chains. Okay, it's only for the straight chains, because if you see the like a circular chain like benzene, cyclic benzene, like something means you will not find it. Only for like alkanes. Only for I'm writing only for alkanes, alkynes. Okay. So for this I'm writing a sigma bond. This is atomicity. We have done 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Total number of atoms is equal to atomicity. So where atomicity has 8 minus 1 is 7. So 7 sigma bonds. If you calculate it, you will get it 1, 2, 3, 4, 5, 6, 7. So we got 7. So as the formula also you can got the 7. So before wearing, if they given any organic compound C3H6, C3H4 like that, any organic compound, then take the atomicity and directly -1 means will get the how many sigma bonds present in that one. But you want only for alkane. Sigma bonds only for alkane formula. Only for alkane. You want to remember it? You can remember it for only for alkanes means sigma is equals to 3n plus 1. 3n plus 1. You can remember it, but don't use only main this formula because it's very helpful to you. Now I'm drawing one line. Okay. Now let's continue one more example. Before one more example, so we got seven sigma bonds. Alright? Sigma bonds. But how many sigma bonds are there? How many types of sigma bonds is present in that one? We got, if you see here, it's carbon carbon only one sigma bond, but carbon hydrogen six sigma bonds. So C bond C means sp3 has one sigma bond. It's overlapping, one sigma bond overlapping. And carbon to hydrogen, carbon has sp3 hybridization and hydrogen has only S. Okay, six sigma bonds, carbon hydrogen overlapping. Overlapping. So shall we take one more example and close this session? Example 2. Ethylene means C2H4. So the alkene C double bond C bond H. Okay. If you see here, the carbon is sp2 hybridization. Is also sp2 hybridization because there is double bond is attached to them. The double bond attached to them for this carbon and this carbon. I am not considering the hydrogens, only I am considering the carbon between the bond. Double bond is attached to them. So sp2 hybridization. If carbon has another carbon attached with single bond also, but only double bond is considered. Next double bond is equal to, and hydrogen atoms. If you see this hybrid orbitals sp3, sp2 means 3 hybrid orbitals is also s3 hybrid orbitals. Means hydrogen atom is equals to hydrogen orbitals. Hybrid orbitals is equals to 3 plus 3 is equals to 6. 6 hybrid orbitals, and number of pure orbitals is equals to number of hydrogen atoms. You should know 1 2 3 4. Okay, 2 3 4. So 4 plus 2 into number of pi bonds. If you see here, double bond is there. So one pi bond, one sigma bond. One pi bond, one sigma bond. So one pi bond, 1. 4 plus 2 is equals to 6. So hybrid orbitals is to pure orbitals means 6 is to 6 equals to 1 is to 1. 1 is to 1. So it is the ratio for the hybrid orbitals and pure orbitals. Then next, what is atomicity? If you see the atomicity, 1 2 3 4 5 6. Atomicity is equal to 6, and number of sigma bonds is equals to atomicity minus 1. So 6 minus 1 is equals to 5. If you see here, sigma bonds 1 2 3 4 5. So it is very clear that the formula is useful for this. Okay, and 5 sigma bonds. How many out of there? Carbon to carbon, carbon to carbon, sp2 and sp2 hybridization. Hybridization here 1 sigma bond, and carbon to hydrogen 4 sigma bonds, 4 sigma bonds, sp2 and s overlapping, overlapping. It is very useful. This is also a competitive exam question, because they will ask in alkene what carbon to carbon, what is the overlapping between carbon to carbon, and what is the overlapping between, which type of overlapping between carbon to hydrogen. So you should know that it's the sp2 and s between carbon and hydrogen, and carbon to carbon is sp2 sp2. They'll ask by the alkene alkane alkyne. So three has different overlapping, sp sp2 sp3. sp means triple bond, sp2 means double bond, sp3 means single bond. Okay, by this way we have highlighted, and I'll explain one more example for alkane also. Is it clean? Is it clean? C2 C2H2 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 alkyne 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 means I'm writing the diagram. H bond C, triple bond C bond H, sp hybridization means here sp means two hybrid orbitals, here two s means two hybrid orbitals. Hybrid orbitals is equals to 2 plus 2 is equals to 4. Pure orbitals is equals to number of hydrogen atoms 2, 2 plus, and 2 into, we will find here triple bond means 2 pi bonds. 2 pi bonds means 2, this 2 plus 4 equals to 6. We find the ratio hybrid orbitals is equals to pure orbitals. 4 is to 6, which means 2 is to 3. Here you see 2 is to 3. Okay. Then next, atomicity. For calculating atomicity, if you see here, atomicity is equals to 4, means sigma bonds is equals to atomicity minus 1, means 4 minus 1 is equals to 3. If you see here, only 3 sigma bonds is present here. 1, 2, 3. Other two are pi bonds. Okay. So 3 sigma bonds just to carbon sp and sp hybridization. You see, overlapping. Only here 1 sigma bond is present, and 2 sigma bonds are present between C and hydrogen. Means 2 C2C C2H, 2 types of means sp and s overlapping will be seen here. So it's a complete one, but sometimes some questions will raise. Sometimes some questions will raise that how many number of present in benzene. So can we see it's working with benzene or not by cyclic. C6 6 C6H6 for benzene reaction structure C bond C bond C bond C C C. Sorry, yeah, correctly not been done. So double bond between two atoms. Two atoms. Two atoms. Okay. The hydrogens are connected like this. So I'm checking by structure. Also, first time by structure I am counting 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So if you see for from carbon to carbon, for every carbon there is a sigma bond. Means 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 12 sigma bonds. 12 sigma bonds. And 1, 2, 3. 3 pi bonds. 3 pi bonds. By the atomicity, how can we calculate by atomicity? Let's check it. Atomicity means you should weigh how many number of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 11, 12. So atomicity 12. 12 minus 1, you can't calculate it. Yeah? You got 12 sigma bonds here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 12 sigma bonds. We will find it here. But by atomicity, it not work. Atomicity means C6H6 means total 12. 12 means we can't find it. 12 minus 1, 11 is coming. So it's only works, this formula is only works for alkanes, alkenes, alkynes. For benzene like cyclic components, you should weigh the structure and then calculate the how many number of pi bonds and how many number of sigma bonds present in that one. Okay. So thank you students. Thank you students. Please subscribe my channel. It was new channel. Please subscribe my channel. It is very helpful to me, and please do like, share and subscribe, because so many members are suffering for this reactions and for this matter. So it's very helpful for them to find out this theory. They will also get helpful for this, and I was satisfied with that. I have helped for someone, so I'm keeping these videos for you. So please do subscribe and please do subscribe and like, share, subscribe. Thank you. If you like my channel, if you do like my channel, if you feel happy with this video, it's very helpful to me. If you feel this happy, then I will see how many likes are there. I will see by the likes only. Okay? Thank you. I will be seeing you in next video. Thank you.